Hello there, welcome to this video. We are talking differentiating trig functions. So everything that we've done with derivatives thus far with other types of functions, we're now going to go ahead and introduce with trig. All right, so let's go ahead and get this topic started by looking at the graph of sine of x at the right. And what we're going to go ahead and do is at all the kind of main angles, what we're going to do is kind of draw a slope field. So estimate the slope field. So I'm looking here at negative 2 pi, and that looks like 1. Here at negative 3 pi halves, so it looks about 0. Here it looks like negative 1, 0, 1, 0, negative 1, 0, and excuse me, and 1. So, okay, now I'm going to go ahead and I'm just going to plot those points on this graph, and this is f prime here. Okay, so at 1, 1, and then 0, and then negative 1, and then 0, and then 1, 0, negative 1, 0. And I hope you noticed a pattern. And here is our graph. I'm going to go ahead and graph this. And what does that look like? Well, this looks like cosine of x. And that is the derivative of sine of x. It's cosine of x. Okay, so again, we take the derivatives of our functions by analyzing the slopes at certain points, and that is the derivative. Okay, so here is a table of the derivatives, and for our initial values, kind of the main ones that you're going to have to know, right? Like, what's the derivative of sine of x? What's the derivative of cosine of x? What's the derivative of tangent of x, cotangent of x, secant of x, and cosecant of x? Okay, so these are just things that you're going to have to memorize. And then what I want you to see here for the sine of u, right? This is just the chain rule version of it, right? So if I have a function of the inside of my trig function, I have to utilize the chain rule, derivative of the outside times derivative of the inside. Okay, and then something else to keep in mind too with all these cos, we get a negative, right? So derivative of cotangent, it has a negative. Derivative of cosecant, it has a negative. So that's just something to remember, to memorize. And at the beginning, what you're going to have to do is just keep this chart by you when we're working on these problems. And then hopefully after a while, you have the memorization skills to be able to do this. Now, again, I've talked about this before. Flashcards, flashcards, flashcards. These are things that you are going to have to memorize. No way around it, okay? There are some pattern to them, so you can kind of develop the pattern and kind of have a strategy for memorization, but that's something that you're going to have to do, all right? Okay, so let's go ahead and look at some examples. Let's differentiate, and our first example is cosine of 3x squared. Okay, so the derivative of cosine, I know, is negative sine of 3x squared, but then I also have the derivative of the inside. Okay, so the derivative of the inside is 6x. Okay, so that gives us negative 6x sine of 3x squared. Okay, and there it is. Hey, pretty simple. All right, number 2. Y is equal to tangent to the fourth of 5x. And this is just kind of something that they do with trig functions. So I have tan of 5x raised to the power of 4. So that's really what we're looking at. Okay, and if we want the derivative of this, if we want y prime, okay, so I'm going to go ahead, and this is totally like chain rule, right? Power rule, so 4 times tangent of 5x cubed. Okay, now I have to do the derivative of the inside, right? And derivative of tangent is secant squared, okay, of 5x times the derivative, again, of our angle, which is 5. Okay, and there is y prime, which if I clean this up, we have 20 times tan cubed 5x times secant squared of 5x. Okay, and there you are. There's your y prime. Okay, so lots and lots of chain rule. All right, next, cosecant of, or f of t equals cosecant of t over 2. Okay, so I know that f prime of t, I'm dealing with a co, so I'm going to have a negative. So I'll put down my negative, and cosecant happens to be negative cosecant. Sorry, so negative cosecant of our angle, so t over 2, okay, times cotan of our angle, t over 2, okay, times derivative of the inside, which is 1/2, right? So, and again, if you want to go ahead and clean this up, we get negative 1/2 cosecant of t over 2 times cotangent of t over 2. All right, and there's f prime of t. Okay, next, g prime of x. All right, g prime of x. Okay, so what I hope you see is you have e to the power of negative 2x times, computers being funky, times cotangent of x. Okay, so what we have is the product rule, right? Also along to, right, I hope you see a function in your exponent, so we have chain rule coupled there. Okay, product rule. So I'm going to take the derivative of the first. Well, derivative of e to the x is just e to the x. Okay, so, but I have negative 2x, so I have chain rule, right, times the second, so cotan x. All right, plus, now, okay, again, the first times the derivative of the second. Okay, and the derivative of cotangent is negative cosecant squared of x. Okay, and there it is. If you want to go ahead and kind of clean house, I mean, you can. So you have negative 2e to the negative 2x cotangent of x minus e to the negative 2x cosecant squared of x. Okay, and if you wanted to factor out e to the negative 2x, you could also do that, but that's good. Okay, now let's go ahead and it says without a calculator, they want us to find the slope of the graph of y equals 3 cosine of negative x, where x is pi halves and negative pi thirds. Okay, so the first thing that we need is we need y prime. So I have y prime is 3 times cosine of negative x. Well, that is negative sine of negative x, and then times the derivative of the inside, which is negative 1. So this is just 3 sine of negative x. Okay, so there is y prime, and now all I have to do is go ahead and evaluate at pi over 2, right? So y prime at pi over 2 is equal to 3 sine of negative pi halves. Okay, and at negative pi halves, okay, if we're thinking unit circle here, okay, that is right here, right? And the y value there is negative 1. Okay, so 3 times negative 1, which is negative 3. And there's your answer. Okay, how about y prime of negative pi thirds? So the same thing, I use my derivative, and I evaluate at that x value. So negative, negative, right? Negative times a negative pi thirds is just going to be positive pi thirds. Okay, and I know that at pi thirds, this is root 3 over 2 using my handy dandy hand trick. And there's your answer. Okay, aren't those simple? Super simple. All right, example 6. We have a limit of x going to 1 of tangent of x minus 1 over natural log of x. Okay, so, Let's go ahead and evaluate. What if I just plug in 1? Well, I have tan of 1 minus 1. Okay, that's 0. Okay, so tan of 0, well, that value is 0. Woo! I don't think it likes being zoomed in that much. I think that's the issue, okay? All right, and then natural log of 1, that is also 0. Hey, so we have L'Hopital's. So I'll go ahead and rewrite this limit as x goes to 1. Okay, the derivative of tangent of x minus 1, well, that is secant squared. Okay, so secant squared of x minus 1 times the derivative of the inside, which is just 1. And then what's the derivative of the natural log of x? Well, that is 1 over x. Okay, and if I go ahead and if I plug this in here now, I get secant squared of 0 over 1 over 1. Okay, and remember, secant squared, so that's 1 over cosine. Okay, so 1 over cosine at 0. Well, cosine at 0 is 1. So this is 1 over 1 over 1 over 1. Okay, which is just 1. And there's our answer. Okay. All right, now let's go ahead and look at some applications. I want to find the x values of the relative extrema for the function f of x equals sine of x minus cosine of x on 0 to 2 pi inclusive. Okay, so again, if I want extrema, what I need is a derivative. So I need to know what is f prime of x. Okay, so, derivative of of sine is cosine of x. Okay, minus the derivative of cosine is negative sine of x, which happens to be cosine of x plus sine of x. Okay, there's my derivative. And what I want to do is I want to set this equal to 0. Okay, so I want to know where is negative sine of x equal to cosine of x. Pretty much where the values equal, but opposite, right? And if I draw a coordinate grid, right, and a unit circle, well, that's going to happen at pi fourths, right? Root 2 over 2, root 2 over 2. Okay, so in what quadrants are they opposite? I'll let you think about that while I'm writing down my angles. Okay, here's where they're equal. So I know they're the same sign right here, and I know they're the same sign in quadrant 3. So that's going to be at 3 pi over 4 and 7 pi over 4. Okay, so I have extrema here, which means mins, max. Now, which type? Okay, so I'm going to go ahead. I'm going to draw an f prime number line. Here is 3 pi over 4, 7 pi over 4. And what I'm going to do is I'm just going to test a value. So pi happens to be right in between there, here. Okay, so I'll plug in pi here and pi here. Okay, so cosine of pi, well, that's -1. So -1. And then if I plug in sine of x, that's 0, so -1. Okay, so this is negative. And then what happens if I plug in 0? And then also, let's say 2 pi. Okay, so that's right here. Well, if I plug that in, that's going to give me a +1. Okay, 2 pi. That's going to give me a +1, so this is positive and positive. All right, so our graph is increasing, decreasing, and then increasing, which means that this is a max, and this is a min. Okay, so here's your answer. A relative max at x equals 3 pi fourths, and a relative min at x equals 7 pi fourths. All right, there you have it. That is derivatives of trig functions. Memorize those, all those trig derivatives, okay? You need flashcards. Do it with a buddy. Put that in your head. All right, catch you next time. Peace.